In Module 6, you learned about climate change scenarios and changes that we might expect to see in the future. Evidence is accumulating, though, showing that many ecosystems around the world are already experiencing impacts. In some cases, these impacts are a sign of things to come and show the breadth and the scale of impacts to which we may need to adapt. It's important to think about the system as a whole here. How does the loss of an amphibian in Costa Rica affect the life of a plumber in Berlin? Does bleached coral in Australia matter to a lawyer in Tokyo? The impacts of climate change are about cascading influences that can reverberate around the globe and through both natural and human systems. To begin our examination of climate change impacts, this lecture will introduce you to observed climate change impacts on a variety of land-based natural systems. While we can't possibly explore the full range of impact scenarios, you'll be provided with a taste of the planet's most vulnerable ecosystems and a foundation from which you can continue to learn about second and third order climate change impacts. To begin, we'll consider those climate change impacts that we've already begun to see around the globe, with a particular focus on terrestrial biological systems, including plant and animal species, and coastal systems. These impacts on natural systems, as we'll see later on, are directly related to the capacity of the planet to respond to shifting climatic patterns and provide for the needs of humans. I encourage you to find out more about these impacts by digging deeper into the report of Working Group 2 of the Intergovernmental Panel on Climate Change, as well as regional assessments that might be available to you. These additional resources will be provided throughout this module as well. Think about the ecosystems in your own region and do some digging to see if there are changes occurring close to home. After decades of studying ecosystems, we know that plants and animals function best within a particular climatic range. Water availability, ambient temperatures, and the availability of nutrients all dictate the success of one type of ecosystem or species over another, and that has yielded the current distribution of ecosystems that we see today. If climatic conditions change, plants and animals respond in a number of ways. Timing of key events, like blooming of flowers or mass migrations, may shift to earlier or later in the season. Populations may shift to a new geographical location that provides the conditions under which they function best. In a warming climate, this often means either moving poleward geographically or to higher elevations. Particular genetic varieties may find greater success, while others fall away, and this yields changes in shape, the morphology, or reproductive habits. Finally, if suitable conditions can't be found, plant and animal species may simply become endangered or extinct. We find this with species that are particularly constrained geographically or unable to adapt. Studies from virtually every region in the world have shown that climate change, along with other drivers like land use change, is producing all of these results. In North America, for instance, the leaves of some tree species are unfolding progressively earlier in the spring in response to higher temperatures. Similarly, tree lines, or the boundary between habitable and uninhabitable environments, are shifting both to higher elevations and to higher latitudes. Why does this matter? Well, economically valuable tree species may be moving into new territories in which the industry's infrastructure, like logging roads, pulp and paper mills, and labor, don't exist. This gets even more complicated if tree species can no longer survive in a particular jurisdiction or country, but flourish elsewhere. This is the complex part of climate change impacts. Some groups will win, while others will lose. In Europe, as in North America, bird species appear to be particularly affected by the warming that we've already experienced. Some species of birds, for instance, are laying eggs earlier in the season, and several species of birds no longer migrate out of Europe at all. Powerful evidence for warming in the United Kingdom is provided by significant northward shift in about 329 bird species. These species are taking advantage of an extension of their range into previously cooler regions, while the southern regions of these species' habitats may soon contract as temperatures rise to levels outside of their coping range. Around the world, we see that there are some species that are particularly sensitive to climate change. Amphibians, in particular, have been devastated by warming temperatures. It appears that in some regions, warmer weather is leading to the explosion of a fungus that is fatal to hundreds of amphibian species around the globe. The flourishing and eventual domination of some invasive species is also a hallmark of a changing climate. For instance, southern species of barnacles in Europe have overtaken the habitats of their northern counterparts, and they have increased overwinter success in these areas and reproduce more rapidly. While we may be willing to trade one species of barnacle for another, the implications for biodiversity are actually pretty serious. A warming climate and changing precipitation patterns also impact terrestrial ecosystems that are of direct value to humans. Longer growing seasons and the fertilizing effect of CO2 in the atmosphere have actually caused an increase in net primary production, or vegetation growth, in both the northern hemisphere and the tropics. This figure shows estimated increase in plant and tree growth during the period of 1982 to 1999. In some places, though, this has been offset by the impact of pests like the bark beetle, which thrive in warmer temperatures and have been chewing their way through forests in the United States and in Canada. On the agriculture front, some crops are expanding their range in a changing climate, while others aren't doing so well. Maize and soybean crops are showing increased yields in some regions, while hay in the United Kingdom and rice yields in the Philippines have gone down. Since, as we've seen, rising temperatures lead to the thermal expansion of water and the rapid melting of land-based ice, rising sea levels have become a great cause of concern. Impacts on human cities and livelihoods aside, rising sea levels have contributed to dramatic levels of shoreline erosion. The result is that previously sensitive habitats, such as the spectacularly productive intertidal zone and tropical mangroves, are being squeezed between higher sea levels and uninhabitable inland geography. Beach erosion is exacerbated by human activity like mangrove clearance, and it's being witnessed from the UK to Australia. Marshlands, or wetlands, serve a number of critical functions. They're natural barriers to flooding, they purify water, and they're considered some of the most biologically diverse habitats on Earth. They even sink carbon. But altered tidal dynamics, human interventions like reclaiming land for development, and rising sea levels are contributing to the degradation of wetlands. We've seen this in many places around the world, like in Louisiana after Hurricanes Rita and Katrina, and in the Thames estuary in the United Kingdom. As sea levels rise, a phenomenon called coastal squeeze occurs. The ocean overtakes wetlands on the coast, but there's nowhere for them to go since they're backed up against natural or human-made barriers. Take a moment to zoom out a bit and think about how human activities are affecting these coastal systems. Dams prevent sediment from reaching deltas and accumulating in these rich wetlands. The heavy use of fertilizers change nutrient cycling in these systems, causing mangroves to encroach on other wetlands. Wave action, higher sea levels, and storms chip away at coastlines, some of which are left more fragile by bleached coral. This is why we think about coastal systems as being so vulnerable. Multiple impacts are at play here, not just sea level rise. Some of these problems seem pretty overwhelming, but really interesting actions are being taken around the world to preserve species, to protect coastlines, and to address some of these climate change impacts. In the UK, for instance, a major project is underway on Wallasey Island. A series of salt marshes are being constructed along a coastline that had once been reclaimed from the ocean. These wetlands are providing invaluable habitat for birds, for amphibians, and for a variety of plant species as well. This stretch of coastline is also more protected from rising sea levels and wave action, and in a way that's more resilient and provides more benefits than simply building a wall. We'll talk more about these ecosystem-based approaches to managing the impacts of climate change in Module 9 of this course. Other steps can be taken to tackle the multiple impacts on coastal systems. Managing the use of fertilizers and controlling runoff helps to prevent elevated levels of nutrients in these systems. Preserving the intricate mangrove forests that are found on nearly 3/4 of tropical coastlines can help buffer coasts from waves and from storms. By creating protected areas and making sure that animals are able to safely migrate, breed, and feed, we can help to ease the stress of a warmer climate. During this lecture, we've been introduced to a variety of climate change impacts on natural systems. While these don't represent the full range of impacts we're both currently experiencing and expect to experience, they do allow us to gain some idea of the breadth of challenges that natural systems face. Perhaps most importantly, human activities often exacerbate the effects of a changing climate, yielding unintended consequences. We've explored the changes already being observed in both terrestrial and coastal systems, such as the poleward migration of thousands of species and massive coastal erosion. We've dipped into the world of responses to these impacts, including the preservation of species habitats and wetland construction. Now let's move on to impacts that are relevant to over 75% of the planet, freshwater and marine ecosystems.